One of the most important synthesis in organic chemistry is the Malonic ester synthesis. So today we are going to learn how this process of the Malonic ester synthesis takes place, and also we are going to revise a question paper on the same process. So we are going to learn about the Malonic ester synthesis. The Malonic ester synthesis. So a lot of students get confused. What's this Malonic ester synthesis? From the word ester synthesis, they think like this process will produce an ester, but that's not the actual thing. So the thing is, this process produces a substituted carboxylic acid. So this process produces a carboxylic acid. So it's one of the process where you can synthesize a carboxylic acid. So the final product that we expect at the end of this process is the substituted carboxylic acid. So substituted carboxylic acid. So Malonic synthesis process only takes place in, I may say, 4 stages. So the first stage or step is formation of an enolate. So the first step involves the formation of what? Enolate. What's this enolate? Enolate is an ion, so I will indicate to say formation of enolate ion. That's the first step. Here we are using a strong base. A strong base is used to form an enolate ion. Now the starting material is dimethyl malate. So the starting material is dimethyl malonate. We are going to discuss it at a later stage. So that's the first stage, formation of enolate ion. So here, most of the bases that is being used is a strong base. So for your own information here, using a strong base. Example of a strong base that we can use to form enolate ion is sodium ethyl oxide. So you can use here sodium ethyl oxide. This sodium ethyl oxide is abbreviated by this Na or Et. So this is our sodium ethyl oxide. Okay. Step number 2 is one of the most important step. This step is alkylation. When an enolate ion is formed, it reacts with an alkyl halide. So the second step is alkylation. Step number 2, alkylation process now. Alkylation. So once the enolate is formed, the same enolate reacts with an alkyl halide. So enolate ion reacts with alkyl halide. So an alkyl halide, we know is denoted by Rx, where X is the halogen. That's the step number 2. The step number 3, step number 3 here is hydrolysis. So this process involves the formation of what? Ester. So an ester will be converted into a carboxylic acid. In fact, ester groups, 2 ester groups will be converted to carboxylic acid. So the third step here is hydrolysis. Ester group converted into 2 carboxylic acid. The final step now, where heat now is involved, is what we call decarboxylation. So number 4 here, decarboxylation. Decarboxylation, where now in this process we subject the carboxylic form to heat. So heat is being used here. So one of carbon dioxide will be produced, and the final product will be a carboxylic acid. So here we are saying carbon dioxide is removed. What else? You have your final product. Substituted carboxylic acid. This is one of the questions that came in a certain paper, in a certain examination paper. So question 4, they suggest the product to the following reactions and provide the mechanism. So the key part of the question is we need to suggest the product or products, and also we provide the reaction mechanism. So this is the first question, and this is the second question. So let us handle this problem. So we'll start with question A. So question A, we have been provided with a dimethyl malonate. in places of sodium ethyl oxide and our alkyl halide. So we're going to start with the starting material here. So our starting material is that's our starting material. So we are going to start with the base that we have been provided there, sodium ethyl oxide. So our sodium ethyl oxide will undergo the process known as ionization. This is very simple, to form Na plus and OET minus. That's the base. So let us just dive into mechanism, meaning we need to put our non pairs. And this is the base that we're going to get. Now we remember carbonyl alpha carbons. The hydrogen of an alpha carbon or hydrogens of alpha carbons are acidic in nature, meaning here we have two hydrogens here. So these hydrogens are acidic in nature. So the base is going to come and get one of those hydrogens. The base will come and grab one of those hydrogens, these two hydrogens, to form an ion. So the product here will be, this part is not tempered. Okay, we see a negative. It has become a base now. So this is the first step. If you want, you can add as well this product which has been formed, HOET. But our main focus is on this, the first one. Okay, now we'll dive into the second step. The second step, we're going to get an alkyl halide. In this case is our bromobutane. So our 1 bromobutane, 1, 2, 3, 4. From here now, this ion, the negative charge, will come and attack this carbon which has a bromide, expelling this bromide. So that's what we call SN2. So this will undergo SN2 reaction mechanism. So meaning our product here will be nothing but OET connected to okay, so that's the product. discuss the second step, which we said alkylation step. From here now we're going to add an acid. Allow me to get this same product. Now we're going to add acid. This process now we're going to add acid. So allow me to add 12 of them on different sides here and there. Let me have the ink. So here allow me to put in this ink positive, then here another acid, positive. Now the thing here is we want to make this as a good living group, because here the way it is, this oxygen is having 2 lone pairs. It is a bad living group, so we want to make it a good living group. So we want to make this a good living group. How we're going to adjust this into an acid, meaning oxygen here is going to use its lone pair, grabbing the hydrogen there, expelling that bond. Okay, the same thing will happen here. Okay, so after this process, our product here now will be with hydrogen added. The same here. Put the hydrogen on top. Then automatically this will be positive, and this will be positive. This is a good living group. Connected to, don't forget this. So that's the product. From here now, remember we have the other product here is water, which is this, and again on the other side is also water. Now water now as a neutral will act as a base, attacking this carbon there, the middle carbon. This will result into breaking the pi bond. The same thing will happen here. This will attack the carbon there, then the bond will break. Okay, from here now, after the pi bond has been deformed or has been broken, meaning this carbon has ability to replace it again. Allowing this to leave. The same thing will happen here. This product will leave. So our product B this group was been removed, so it's O the water which has been added there. Then here again the water which has been added. This pen is giving me problem. Then with a side group. Finally here now we are going to use water again. It's going to get away the hydrogen there. The same here. Okay, now our product will be a carboxylic acid. Okay, so that's the product. That's the product after adding the acid. So here now, that's when now the last step, which is decarboxylation process, takes place, meaning we're going to heat now. We're going to heat. So heating will make this oxygen to grab the hydrogen, and then this will make the formation of a double bond, another double bond between carbon and oxygen, expelling this bond. So meaning the product which will be formed there will be carbon dioxide. Okay, so here, meaning this part will leave. So we're going to have something like this. It's a positive charge, but this is connected to plus carbon dioxide. So this will escape as a gas. The final step will involve getting rid of your hydrogen here. You can also use water to get rid of this. and you have your carboxylic acid. How many carbons? 1 2 3 4 5 6. 1 2 3 4 5 6. 1 2 3 4 5 6 with OH here plus carbon dioxide. So this is the end of the first question. This is the mechanism of the first question. So the answer here is carbon dioxide and our hexanoic acid and the carbon dioxide. So meaning here our answer for the first question is one, two, three, four, 5, 6. This is the product. Now you are going to follow the same step to answer the second question, but here now you are going to add the alkyl halide twice, because we have this step is repeating itself at 2 and at 4. So meaning all the hydrogens here, the hydrogens will be replaced by, the first one will be replaced by this one, this hydrogen, and this hydrogen will be replaced by the second one. Okay, let me just write the answer so that you should just do the mechanism. Don't get confused. This is very simple. So like what I've said, let me remove this part. You see this molecule, the malonic ester, the starting material here. Let me get another ink. Okay, let's just divide this into 2. You have seen it. So that's where now the easy part of this molecule comes all about. So you get just the one of the part, the left side in this case, your oxygen here. This OET is replaced by OH. Just put your OH here. Have you seen? Now let us denote this as carbon number 2. 1 2 here, 1 2. Now the carbon 2 will be just connected to these 2. So I'll start with this one. 1 2 3 4. From here, 1 2 3 4. 1 2 3 4, meaning it is this what, the first one, meaning we are done with the first one. For the second one, 1 2 3 on carbon 2. 1 2 3. Yeah, this ink is not good. 1 2 3. Then just get there's a double bond here at the end. You put just a double bond here. That's the answer. Meaning you have formed a substituted carboxylic acid, because in this case we have used 2 of now alkyl halides. We need to add 2. That's the final answer. That's the final answer. So if you find this video useful, please subscribe to my YouTube channel. So tomorrow, in my next video, we are going to learn about another process similar to Malonic synthesis. Shalom, shalom.